My
name is Jürgen Speck. I am marketing manager of BRAUMAT and SISTAR. Today, we are launching a new video platform on which we would like to present the latest developments and functionalities of BRAUMAT and SISTAR in detail. We are starting with the current BRAUMAT version 8.0. Let us surprise you with the new features we have for you. We start today with the graphical recipe system and show the special features of the synchronization with BRAUMAT. BRAUMAT synchronizations run on the recipe server. Our specialist Horst Fuchs will now give you a live presentation of the BRAUMAT graphic recipe system. Thanks, Jürgen. Today, we will show you the graphical recipe functionality of BRAUMAT. Well, let's assume your customer provides you a process description. You must now interpret it and transfer it to the project. For this we use the recipe editor, which is divided into two parts. The upper level for entering the graphical steps, and the lower half is used to enter the corresponding process target values. These parameters can be fixed or, depending on the master recipe type, they can be entered in a large table and later substituted at the appropriate place. Thus, we have absolute flexibility and transparency within the recipe system. As already mentioned, we can select the place steps with corresponding names from a prepared pool of steps. Furthermore, we can connect corresponding units, i.e., the aggregates within a system by means of synchronization. These synchronizations serve on the one hand to start a second one from an existing timer position, or to artificially introduce a waiting time at the corresponding synchronization points until these two units are synchronized again. The advantage? These synchronizations do run on the server, not in the AS. This makes the procedure extremely transparent. We can see this here in the online view of a recipe. This is the active step. This is the synchronization before the step. If we see this light green mark twice at those 2 points, I'll make it a bit bigger, then we know that the synchronization has been processed correctly and that we can continue with the next step. The active step, marked yellow here, is set to stop. i.e., we have stopped processing now. We can see the target values here, either the absolute or the recipe dependent, and the corresponding current actual values. We get the actual values from the periphery. We look at the whole thing in the process picture and follow the process sequence of this meshing. As already mentioned, there is a meshing in step heating up with a certain set point, and now I let the plant section run again. Of course, we can also view the set point actual values within the process picture on the corresponding plant section display. This heating step does two things. We will be able to see this later in the programming. It activates the agitator and one of the steam valves. And we're basically waiting for the target value to be reached 53 degrees Celsius. Then there would be a step change, i.e., we jump from this step heating to the next rest. Here in the online view, you can see the step number and a marking FC 1067. Those familiar with schematic software will quickly recognize this. That is the designation of a function block. We can now turn to TIA portal. In TIA portal, we have started a complete AS project for this AS, including the steps. And this heating step here is shown online. We are basically in this variant of the step. Variants can also be recipe parameters. It is about this variant how many steam valves we want to activate. And we ask for this with these commands. And a steam valve is activated. Including the connection with an attribute on the unit, namely the hold attribute, we can implement a further interlock here. i.e., always, and now please note the difference, agitator valve, whenever I set the subsystem to hold, the corresponding steam valve is deactivated, but the agitator remains active. That is this command up here. The last command within a step is always the step on condition. We link this to another attribute. And this attribute is 1. It is true when the actual temperature value and the setpoint value match. We now provoke the step change and wait until the temperature exceeds 53 degrees Celsius. And then you see, the graphic recipe jumps automatically to the next step in a rest period. A timer starts and the whole recipe runs through until the next synchronization. And a new unit then starts here. And so, you can always be sure within this graphic view where your batch is now within the processing. Including all information regarding set points, actual values, step numbers, and so on.
Siemens. Ingenuity for life.